I promise to get to the point where I explain why we don't tend to get good pure snowstorms in the region, but I've started off with two things that are important, and that is looking at the weather pattern as I saw and shared before. And just as a reminder, we need a negative EPO, which if you look back, that is a ridge you see going up into Alaska. The way that it causes that is it actually then will cause cold air to stream all the way from the pole. A positive Pacific North American, which is a ridge or a high pressure along the west coast. We get a negative Arctic oscillation, which will help to bring cold air down to the United States, and then a negative North Atlantic oscillation, which is a area off of Greenland that if we get a block there, will block cold air and keep it into the region. So these are all things that can be favorable for us. And honestly, if you look for a checklist of things you're going to look for in a snowstorm pattern, those are the things you're going to look for, and I'll talk about that specifically later. But one thing that we have as a saving grace in the Mid-Atlantic region is something called cold air damming. That is if you like winter weather. Cold air damming is caused specifically because of the mountains that are off to the west. These mountains can trap colder air east of them and provide enough cold air for wintry weather, even when maybe the pattern isn't perfectly ideal, especially high pressure systems up to the north. Now, if the high is in the right location up near Canada, that cold air damming will just funnel in enough cold air and it will be enough and deep enough into the atmosphere or high enough up in the atmosphere that will cause snow. But it often will cause a mixture of precipitation because warmer air will override the colder air at the surface and either be sleet if it's cold for a long enough column or freezing rain. We get this quite a lot. There's two types of cold air damming, and I'll explain those in just a minute, but just to kind of give you a visual here, this is by Jack Sillen on weather.us, another good site that's out there for you to take a look at. So basically you get the high terrain, the mountains, and there's this trapped colder air that you're seeing here that's up against the mountains. You get the warmer air that kind of goes up over top of the colder air at the surface, and depending on the depth of the cold air will depend on whether or not you get your precipitation, meaning sleet or freezing rain or snow. And so here you see the warmer air is coming in, but if it's cool and not cold, then it can stay cold enough for it to be snow in that area, versus freezing rain, which tends to be also an issue. Now, I mentioned two types of cold air damming and cold air situations that you've set up. One is called in situ, meaning what it is we have a really, really cold air mass in place. It's really, really cold. The ground temperatures are below freezing, and you get this warmer air that overrides that cold air at the surface. And that's just leftover cold, stale air that can stay there and be colder than the warmer air over top of it. And the cold air doesn't have a chance to get out of the way, so it's dense and it stays locked into place, and so it stays in place, and a lot of times that's when you get your freezing rain type scenarios. So that's not when you get cold air filtering in, that's cold air that's already there, and as I say, it becomes stale because the high that was delivering the cold is already moving away, but it's left this cold air at the surface. So that's one option. The other one is the filtering of cold air east of the mountains. So this is what you kind of see within a setup where you would see that. The high pressure system over Canada, ideally you're looking for a high pressure here and westward in order for it to be a snow situation for us because the cold air source is really, really strong. When it gets this far east, cold air can still make it around and it starts to get pushed up against the mountains. And you see the isobars, which are the pressure lines along with high pressure system. You'll see them do this sagging down here east of the mountains. That is a strong indication of cold air damming. You can see that on temperature maps if you ever look at temperatures out there, and you're going to see this colder air up east of the mountains. Again, depending on the level of cold air dammed up against the mountains could mean the difference between snow and not snow. And as we get later in the season and the temperatures aren't as warm, so we've got cold air kind of around, a cold air damming scenario can give us a lot more snow than it would earlier in the season. A lot of times, though, they cause a mix of precipitation, and that's what we see that happens. The other thing that we have here, so here's the temperatures, as I mentioned. So it's coming in, and you get the cold air east of the mountains. Depending on the depth of the cold air would then depend on what type of precipitation that you would get. The mountains of North Carolina are notorious for this type of scenario where they get in Southwest Virginia, where they get a lot of freezing rain and ice storms down that way. We are far enough north here in Loudoun County, where I live, in places where enough cold air does drain down a lot of times for at least the western part to remain a mix of snow and sleet, whereas the eastern parts may see freezing rain and sleet or freezing rain itself. It just depends on exactly, like I said, where that high pressure system is to the north and how far down east of the mountains it can flow. And so that's kind of what we got going on from there. Again, just as a reminder, if the precipitation can fall through a more isothermic, we need a cold from the top to the bottom area, meaning basically dendrites, or where snow forms, are in cold air and it can stay cold enough, it will be snow. Otherwise, you get the melting and the warmer air that comes in and melts out, just as a reminder. So again, cold air damming, our friend, thanks to the mountains. And if a high pressure system is up to the north, even if it's not the most ideal situation where it is, like I said, west of New York and over in this region, it can cause this cold air. And sometimes we see that too sticking around when we have cold air in place and a retreating high. And I will tell you that this coming week, towards the end of the week, a storm is going to be coming towards our area. Cold air is looking like it's kind of retreating. Maybe the block isn't going to do what I want it to do as far as a winter storm. We have to see. And some other scenarios. But basically, because of that, the cold air will get scoured out or moved out because of the wind. But as it starts, it may be some sleet, freezing rain when it starts. That is a low pressure system that's going across the country. And again, the low pressure may not be in the most ideal place. Remember, you want a low to come south of you in order for us to say snow. But with the cold air damming in place, we maybe have a mix of freezing rain and sleet because of the in situ, or the leftover cold, stale air that we have in the place. All right, that was a long-winded explanation of cold air damming. But for the Mid-Atlantic, this is very, very key. And one thing with cold air damming, forecast models have a very hard time picking up on it well, especially early. The more high-resolution models, as we get closer to the event, will pick up on this. And secondarily, cold air is very hard to get out of the region. So sometimes, even though forecast models are showing a changeover eventually to rain, we oftentimes can stay really close to freezing or even below freezing and cause some icing conditions, even well beyond what the forecast models show. So it's a really hard forecast to nail. It's very important for the Mid-Atlantic to know and understand that cold air damming is involved. A lot of times in situations, look for that high to the north, maybe not the most location, or cold air that has been lasting. All right. That was the second in the series of the things that cause Mid-Atlantic snow, and then we will also talk about the things that don't cause it to snow. Have a good one.